0x k0z times c zeta, okay, plus nc squared. K0z squared, zeta squared equal to omega over c squared times nc squared minus ny squared times ny squared minus nx squared times beta squared. Okay. So you see that since we assume that nx is smaller than ny and ny is smaller than nc, so this coefficient is positive. Okay. And how about this one? You can rotate. Now we have variable c and zeta. So you have a c zeta plan. C zeta plan. C zeta is nothing but xz. But we move the origin from the original origin to the k0 point. The new origin here. Okay. So now if we rotate the coordinate system, rotate the coordinate axis with respect to this new origin to a new direction. We can rotate the coordinate axis to the new direction. If we rotate it properly, then we can diagonalize this expression. 说我们实际上，如果我们经过这样旋转，我们可以旋转到把这个交叉项消失掉，变成diagonal form，变成只有平方向，对，可以吧？好，就bilinear form 可以转到让它变成是只有平方向。那这时候会变成什么意思呢？左边是2个平方，右边是1个平方，这是一种什么方程式？So the equation after we rotate our coordinate system, the left hand side looks like this. Say c prime square over a square plus zeta prime square over b square. Okay. Equal to something like this, eta squared over c squared. What does this equation mean? This is a cone equation. What is a cone?我们现在考虑一个简单一点的状况。假设我有这样的方程式 ，Suppose I have an equation look like this. z is equal to c times square root x squared plus y squared。这是一个什么方程式呢 ？x 平方加 y 平方代表的是 the distance from the point x, y, z to the z-axis is equal to the square root of x squared plus y squared. Suppose we have a coefficient c, positive coefficient. Then this equation gives us this surface， 就是它会变成，因为你现在是半径跟 z 成正比，所以它会画出一条直线。但是这个直线呢，其实是什么呢？它是跟方向没有关系，其实转起来就变成一个圆锥面啊，所以就是这就得到一个空，就得到一个空。那如果我把它平方 ，suppose I square both sides, I get the equation of this form. So 这时候跟 c 的正负就没关系，所以下面这个也可以含进去，好，这就变成一个空的 equation， 空一个圆锥的面，圆锥的面。那如果我让它这个锥横截面不是圆形，变成椭圆形，可不可以？可以，它就会变成这样。这也是一个锥，但是它是椭圆的啊，因为这 A 跟 B 可以不一样。啊 ，so this is an cone, this is an elliptical cone, OK。所以基本上这是个 cone 啊，是个锥。那我们现在这个情况基本上都是 elliptical cone 啊，这是一个锥啊，一个圆锥啊，一个椭圆锥啊，椭圆锥。So if you analyze the coefficient carefully, you will find that finally our equation becomes this. Here chi is some angle. OK， 你可以从这个课本的图看出这个 chi 是什么啊 ？Here figure 4.8. You can see the geometric meaning of this chi in figure 4.8. So this cone equation can be rewritten as this form, okay, through coordinate rotation, okay. And if you find the gradient of this surface, which means you find the corresponding group velocity, then you will find another cone. Another cone is written as this. This is the K vector cone. This is the group of velocity cone. Suppose this is the original K vector cone. Then if you find the direction perpendicular to it, and finally you get another cone. This is the cone describe how light propagate, light energy propagate. Okay. And according to this result, we can finally predict this phenomenon called conic refraction. Conic refraction is this phenomenon. Here we have the c-axis. C-axis is the direction of optical axis. And for a beam of light, a normally incident beam of light, the beam of light is K vector close to this K0 point. So corresponding to the local shape of this normal surface, which is a cone, we can predict the light energy propagate along a cone. Okay. So finally, when they penetrate through this crystal, the light energy is distributed in this cylinder, and when it projects onto a wall, we see a ring. 就是那个光最后打出来，你看到的不是点，而是环，而是环状，那这个叫做 conic refraction。那它的理解呢，就是可以从这个特殊的这个 K0点附近的 normal surface 的行为去理解。那这里面具体的这些计算会有很多细节，但是这些你先不用管它。 你就知道有这么一回事就好。好，那我前面这些推导呢，主要目的是告诉你说 normal surface 确实可以弄出一个孔的 equation 出来。好，那你主要需要记得的就是 locally 这个行为是个孔这样子。好，然后这怎么跟这个现象产生连接？啊，这些部分是你需要知道的。好，那具体计算的细节，你有兴趣你再去研究就好。好，那 我们考试也不会去特别考你这些东西。好，那接下来我们就进入到第5章。那第4章的后面的部分呢，我们就留到以后再讲。So now we move to chapter 5. Now we move to chapter 5. Chapter 5, Jones calculus. And its application. we have already learned basic knowledge in chapter 3 about Jones vector. Okay, so now we want to use the Jones vector Jones matrix formalism to study something about crystal and its application. Suppose we consider a piece of crystal, and suppose the c-axis is parallel to the surface of this piece of crystal. And now, this means that when we look at this crystal, this direction, say c-axis direction, we have the corresponding refracting index NE, and in the direction normal to this direction, we have corresponding refractive index NO. Now we consider uniaxial crystal. So if we send a beam of light with specific polarization, if the polarization is along the first axis, this c-axis, then the light feel that the environment has refractive index equal to NE. However, if the light has polarization along this direction, then this light will feel that the environment has refractive index equal to NO. So how about the fact if we send a beam of light having polarization along some arbitrary direction, say this direction, now we can take the two projection of this polarization onto the first axis and the second axis. Therefore, this axis, this component has phase velocity equal to C over NE. And for the other component, the phase velocity is equal to C over NO. So after penetration through this crystal, suppose the thickness of the crystal is L. This component encounter this component get an extra phase equal to minus I K E times L. And this component has phase exponential minus IKO L. And these two components aggregate different phase. So finally, if we add them together, which means after penetration through this crystal, the new polarization will become different from the original polarization. 就是说，我们现在呢，如果考虑一块 crystal， 它的光轴呢是跟这个表面是平行的， 然后我现在呢，如果送一道光直直的进来，那如果光的偏正刚好跟光轴一样，那它就像是在一块折射率是 n1 的介质里面传播一样，它会累积一个光程差，就是 n1 去乘上整个厚度。好，那如果是垂直的方向的偏正的话，它就会累积的光程差是 NO 去乘上这个厚度。好，那这个光程差会不一样。好，那现在如果我送一个任意偏正，我们就可以把它分解成2个成分。好，那它们这2个成分会累积不同的光程差。啊，也就是说不同的相位。好，所以我原来的相位，原来这2个成分的相对相位呢，经过这个 crystal 之后就被改变了。那我们知道改变2个分量的相对相位就会改变偏正状态。好，所以最后就改变它的偏正状态。好，所以我们就可以利用这个 crystal 去改变光的偏正状态。好 ，so we can use a piece of crystal to change the polarization state of the light. Okay. So usually we call the larger refracting index. Suppose we have NE larger than NO, then this becomes the slower one, and this is the faster one. Then we call this axis slow axis and this fast axis, and denote the slow axis as S and the fast axis as F. OK， 好，我们就术语上会这样讲，就是说我们把折射率比较大的那个对应的轴叫做慢轴，然后折射率比较小的那个叫做快轴。好，所以我们就会有所谓的 slow axis 跟这个 fast axis。那我们现在想要知道的是说，当我有这样一块东西，这样一块 crystal 的时候，我把光送进去，它究竟会把偏正转成什么样子？啊，这是我们现在要研究的啊。So now we want to study if I send a beam of light which has specific polarization, then what new polarization will get? What kind of new polarization will we get after penetration through this crystal slab? OK， 啊，那这里面牵扯到一个问题，就是说，如果我是参考原来的 crystal 的轴去看的话呢，这问题其实很简单，就是我把个别的分量找出来，然后看它经历了多少的相位差，然后再叠加起来就好了。可是有些时候我们想要在所谓的实验室坐标系里面去处理，啊，那我们所以我们就要多一个步骤，就是我如何从实验室坐标先转到晶体的坐标，再从晶体坐标去预测它出来会差多少，然后再转回实验室坐标。OK， 所以这数学处理上会多一点麻烦的事情啊，但实际上本质上就是这2个轴提供的折射率不一样，导致结果不一样，就这样而已啊。所以我们这边剩下有一些处理，其实就是在处理这个数学上坐标转换的问题而已啊。So in this chapter, we have to learn something about the coordinate transformation between laboratory frame and crystal frame. Then we consider the effect of the crystal to the light polarization. And then finally we get the result and we want to express it in the laboratory frame. So we change our coordinate axis back to the laboratory frame. OK， 好，所以我们需要做一些这样子的处理。好，那我们现在来看看怎么去处理这个东西啊。So we consider a piece of crystal. This is the slow axis, and this is the fast axis, and this is the x-axis, and this is the y-axis. Okay. So suppose the angle between the slow axis and the x-axis is psi. XY is the laboratory frame. X, Y, Z is the laboratory frame. And S, F is the crystal frame. Okay. So now we study how to express the effect in the laboratory frame. Okay. So in the laboratory, originally we have the vector, polarization vector dx, dy. Okay. This means that v is dx times x unit vector plus vy times y unit vector. Okay. So since this same vector, same polarization can also be studied using the crystal frame, we can write it as Vs times Es plus Vf times Ef. Here, Es, Ef are unit vectors along the S and F axis。就是我们现在，你可以把 slow axis 想成就是光轴啊，然后 fast axis 就是想成是跟光轴垂直的另外一种。所以向量可以用不同的基体去展开嘛，就会有不同的分量，就有不同的分量。So this means that in the crystal frame, the V can be represented by Vs, Vf. Okay. So we now want to study the relation between Vx, Vy, and Vs, Vf. Their relation is in fact very simple. What is Vs? Vs is just Es dot V。OK， 就是你把向量投影在 Es 轴上面啊 ，Es 这个单位向量上面。And now you can write the V as Vx times x unit vector plus Vy times y unit vector. Okay, so you have this Vs dot x times Vx plus Es dot y times Vy. Okay. Both Es and x hat are unit vector, and the angle between them is psi. So the scalar product of them is cosine psi. Okay. And similarly, Es and y, the angle between Es and y unit vector is half pi minus psi. Okay. So the cosine of them is psi Vy. Okay. And we can also find the Vf. Vf is Ef dot V, which is Ef dot Vx x plus Vy y, and this is Ef dot x Vx plus Ef dot y Vy. The angle between Ef and x is psi plus half pi. So cosine psi plus half pi is just a minus psi. And the angle between Ef and y is the same as the angle between Es and x. So the cosine of them is cosine psi Vy. Okay? So finally we can write the result as Vs Vf is equal to cosine psi minus psi cosine psi and Vx Vy. Okay, and I can write this as R of psi as Vx Vy. Here R psi is the so-called rotation matrix. Rotation matrix, rotation or rotational matrix， 旋转的矩阵，那这个旋转就是坐标旋转，就坐标旋转，你旋转到新坐标前后两个坐标里面所看到同一个相的分量的关系就是这样，就这样。这其实可能高中就学过了，或者是 anyway， 反正从前应该学过，那没学过的话就赶快学起来。好，那现在呢？这个旋转矩阵它有一个特性，就是它的 inverse 呢就是倒着转So if I want to study the inverse of R psi, you will find that it is just R minus psi. Okay. R minus psi, and it is also equal to transpose of R psi. Okay, and R psi has the property that如果你转了 psi 2再转 psi 1，不是先转 psi 1再转 psi 2，就跟直接转 psi 1加 psi 2，直接你都可以验证出来。好，那这边为止都只是两个坐标系的坐标轴的转换而已，这没有什么大不了。这边完全是数学，这边还没有到物理的部分。那真正物理的部分是光穿过这个 crystal 之后会发生什么事情？这部分才是物理。好，那我们现在就来看这个光穿过这个 crystal 会发生什么事情。So originally, you have V equal to Vs ES plus Vf EF, or you can write this as Vx x plus Vy y. Now you want to see what is the resultant new polarization vector after penetration through this crystal.好，那现在我们要来看它究竟会变什么。这个假设我把它叫做 vs prime es 加上 vf prime ef。那我们现在看什么是 vs prime， 什么是 vf prime。vs prime is equal to exponential minus I Ks times L. L is the thickness of this crystal. OK， 这原因是因为呢，你原来是个坡嘛，会是这个 exponential 这个形式嘛，exponential I omega t minus K dot R。或者是 k times z 嘛，对不对？那这两个 z 有差别啊，差多少？差一个 l，z 变成 z 加 l， 所以就会出现 exponential minus I k l 这样的 factor。OK， 好 ，so the new vs exponential minus I k s l, which is exponential minus I ns omega over c times L times Vs. Okay? And what is the new Vf? New Vf is exponential minus I kf times L times Vf, which is exponential minus I nf omega over c times L times Vf. NF 就是代表 slow axis 的 n 跟 fast axis 的 n. Okay, so this means that Vs prime, Vf prime is equal to this matrix Vxt minus I ns omega over c times L exponential minus I nf omega over c times L. Vs Vn 0 0. Okay. So now I can write this ns omega over c times L as 1/2 ns plus NL omega L over C plus 1/2 NS minus NL omega L over C. And similarly, NF omega over C times L can be written as 1/2 NS plus NL omega L over C minus 1/2 NS minus NL omega L over C. Okay, so if I define phi as 1/2 NS plus NF omega L over C, and I define gamma as NS minus NL omega L over C, then this part is phi, and this part is half gamma. Okay. So this means that Vs prime BF prime can be written as exponential minus I5 times exponential minus I half gamma 0, 0 exponential I half gamma times BS BF。所以意思就是说，这个新的 BS prime BF prime 可以用一个这样的矩阵去乘旧的 BS BF 去表达出来，好，去表达出来。那这边有一个关键是这样，就是说，我们从前有说过，在第3章有说过，这个多余的 phase 如果不影响它们之间相对的 phase， 这多出来的 phase 是无用的。This phase factor is useless。就是我们只是要判断偏正状态，我们对这个多出来的 phase 没有兴趣。So usually we can ignore this phase factor and write BS prime and BF prime as this. Okay, we ignore this additional phase factor because it is useless when we consider the polarization state. Okay, and I can denote this matrix as W0 matrix. 我们可以把这个矩阵叫做 W0， 或者你要把这个也含进去，叫做 W0 也可以但是那个多余的 phase 其实没有用处至少在我们现在的 polarization 讨论中，它没有用处。好，那么下一堂课来看，就是说，我们现在有了这个 rotation matrix 去管实验室坐标跟晶体坐标然后另外还有这 W0 矩阵去表达这个 polarization 怎么被 crystal 所影响。那我们接下来下一堂课我们就来讨论说，从实验室坐标来看我们送一道光本来的 polarization 经过这个 crystal 最后出来的 polarization 会是怎样，在实验室坐标里面的表达方式。好，那我们这边先下课。